All right, welcome to section 9.2. I am on page 263 of our workbook, page 263. And right here between the two boxes, I'm going to put 9.2. Today we're going to be talking about properties of central angles and inscribed angles. So in section 9.1, we defined what a central angle and an inscribed angle were, but today we're going to again define them and also talk about their relationship in terms of what are called arcs. So first, what is an arc? Well, it says an arc in our vocabulary box. I'm going to zoom this in just a little bit more. Well, maybe I'm going to. Sorry, am I making a little sick? An arc is a portion of a circle's circumference. So remember, the circumference goes all the way around this circle. This is called the circumference, going all the way around it, measuring around. And an arc is just a portion of it. So like from this point right here, B, to this point right here, C, that could be considered an arc. And the symbol for arc is just like what we just made here. It's going to be a little curve over the letter. So that's what we're going to do for an arc. Now, we call an intercepted arc is an arc that lies in the interior of the angle and has endpoints on the angle. So these are endpoints on the angle. So this is called our intercepted, actually. Our intercepted arc. So that's the symbol for an arc, and this is my intercepted arc. Now this actually is a central angle from yesterday, or from section 9.1. We know that a central angle is an angle that intersects the circle in 2 points, so here's my 2 points, and has its vertex, here's the vertex, at the center of the circle. Now here's the relationship that exists between the central angle and the arc. It says the measure of the angle, so this angle right here, is the same as the measure of this intercepted arc. So in other words, if this angle degree is 40 degrees, then this arc will also be 40 degrees. And we know that all the way around, a circle is 360 degrees, so this piece would be 40, and this other piece from B to C this way would be 360 minus 40, which would be 320. So a central angle has the same measure as the arc, okay, same as the arc. Now an inscribed angle from section 9.1 we know has its vertex on the circle, so the vertex is on the circle, and then here in the definition today they say whose sides contain chords of circles. So this is a chord and this is a chord, or in other words, it makes up, they have 2 points on the circle as well. This is called the inscribed angle because the angle is inside of the circle, so we call it inscribed. And again, this is considered my intercepted arc. Now here's the relationship that exists for an inscribed angle. It says the measure of the angle is half the measure of the intercepted arc. So in other words, if this is 40 degrees, then this arc is 80. If this is 100 degrees, my arc is 100, then my angle is 50. This angle is half of whatever this arc is. So we have two different relationships. We have, if it's a central angle, it has the same measure, and if it's an inscribed angle, then this angle is half of this one. So this next vocabulary box kind of puts these two ideas together. So they say ACB, angle ACB is a central angle of circle C. Its arc is AB. So now here's the first time we've seen that notation. So there's the arc symbol. And the measure of the angle, ACB, will equal the measure of this arc. So if this is 80, then my arc is 80. Now they gave us an inscribed angle that has exactly the same endpoints for its arc. And so if this is 80, then that means that inscribed angle will be 40, right? This right here is half of 80. So it's half of this measure right here. So these are the same, and this is half of this measure, and that's what all of this is saying here. Okay, next we name arcs by whether they're a minor arc or a major arc. So first in our vocabulary box it says if the measure of angle ACB, which they didn't really quite draw, but there's my ACB, is less than 180, then A and B and all the points on circle C that lie in that interior of measure ACB form a minor arc. Minor arcs are less than 180 degrees. We call them minor arcs. I'm just going to write it out right here. And a minor arc will be named by 2 points. That's how you'll know that it's a minor arc, because it only has 2 points. So this is considered arc AB. The measure of a minor arc is the measure of its central angle, which we already have defined clear back up here. And then they just, again, talking about this picture, say arc AB is the minor arc of circle C. Now, if it's more than or equal to 180, so greater than or equal to 180 degrees, so in other words, we're talking about the rest of this piece right here, it is considered a major arc. So if you're greater than 180 degrees, then you are called a major arc. So you equal 180 or you're greater than 180, then we call you a major arc. And major arcs, when we turn the page, are denoted by 3 letters. So that's another way that you know that it's a major arc, is that it will have 3 arcs. So the major arc plus the minor arc together will make 360 degrees. So again, as we talked before previously, if this is like 50 degrees, then we know this major arc is 310 degrees, because the whole thing adds up to 360. All right, let's turn the page. The next vocabulary box says A and B are all on points of circle C that do not lie on arc AB form the major arc. So they're saying this is the major arc. A major arc is named by 3 consecutive points, and the measure of the major arc is 360 degrees minus the relative minor arc. So here they actually kind of gave an example. We can see that the minor arc is 60 degrees right here, and then that means that the major arc would be the total 360 minus the 60 degrees would give us the 300 degrees. So this arc of ADB, that tells me that it's a major arc, is 360 minus 60, so this arc is 300 degrees. Now we have a special arc called a semicircle, and it measures 180 degrees. So if we have a diameter, we know that that splits the circle into 2 equal pieces. If the whole circle is 360, then half of it is 180. And a semicircle, because it's equal to 180, will also be named by 3 points. So they say circle D has a diameter of AC. So the semicircle arc would be arc ABC, or you could go the other way, CBA. Now, to get us ready for our next vocabulary box, if I make this inscribed angle right here, so I connect the chords here and here, this is now an inscribed angle, because the vertex is on the circle. And if this is my arc right here, then that means we already know that this is 180 degrees because it's a semicircle. So what does that make that angle right there? Well, remember, the intercepted arc is half of the inscribed angle is half of the intercepted arc. So that would mean that this is 90 degrees. And that's what this next piece is saying. An inscribed angle that intercepts a semicircle is a right angle, because this is 180 and half of it will make that 90. And that's what this is saying right here. This next piece we will use to help us in solving some of our problems today, and it's just the addition postulate that I can add this arc plus this arc, and it will give me the total this way. So if I know that this is 30, and this is a central angle, I know this is 30. And if they tell me this arc right here, let's say is 40, then that means this is 40. And if they want me to find arc MN, then that would be 30 plus 40, which would be 70 degrees. So we'll be kind of using some of that idea. This last piece is just saying that if this is 80 and this is 80, that their angles are equal and their chords will be equal. So if we have chords that are equal, if we have arcs that are equal, then their central or inscribed angles will also be equal. And we'll see that a little bit more in detail a little bit later. Okay, so we're now ready to practice all the things that we talked about. So if you'll turn to the next page and you'll see our practice, your assignment actually is going to look very much like this. You're going to have a set of problems that deals just simply with central angles. You'll see there's no intercepted angles or inscribed angles, there's only central angles. And then our picture down here has all kinds of awesome stuff happening. So let's try 1 through 10 first using this shape. So it says FH is a diameter and JK is a diameter, and we have to find the measures. Now you certainly could just start with the first one and say this as the measure of, notice this is supposed to be the angle, because it's got the angle, and I'm looking for FAJ. So they want me to find this piece right here. Well, maybe you're not ready to find this piece right here, or maybe you see the relationship that exists. But let's just look for a minute at our picture and see if we can get to FAJ. Well, based on my information, if this is a central angle of 65, that means this arc is 65. And if this 50, then that means that arc is 50. And I'm going to blow this up just a little bit more. So it means this arc is 50. And if I notice this is a semicircle right here, then I could do 180 minus 65 minus 50 to find this arc, because this is 180 degrees. So 180 minus 50 minus 65 gives me another 65 right here, which means this angle is 65. Okay, that still doesn't really help me get right here, although maybe some of you realize that here and here you have, do you remember what those are called from a couple of units previous? They're vertical angles, or maybe you weren't sure that those were vertical angles. Well, you could do another piece, and you could see here is a half of a circle, and this is 65. So these two make a straight angle. So 180 minus 65 would make this 115 degrees. And then this right here is another straight angle. So 180 minus 115 takes you back to that 65. So now I finally have this angle, FAJ, is 65. And again, I could have at the very beginning just said that these were vertical angles and have gotten 65. Let's move to number 2, the measure of angle LAH. LAH, oh, we already found that one. That's this angle right here because they want the angle, which is 65 degrees. The measure of angle KAF, oh, we found that one. This one is 115 degrees. Oh, now we're moving to arcs now. Notice the arc symbol above it. So the measure of arc JL. JL, arc. Well, they told me this was 50, so this is 50. The measure of arc LH. Here's L, there's H. Oh, we found this angle by finding it was 180 degrees and subtracting, so we now know that's 65 degrees. The measure of arc HK. Here's H, here's K, another 65 degrees. It's really helpful to kind of fill things in first, and then this goes pretty fast. The measure of KF, well, that's this piece right here. And we found this angle of 115, and this is a central angle, so this is also 115 degrees. The measure of arc JF, that's this arc right here, is JF. Well, if its central angle is 65, so is its arc. Don't forget your degree sign. The measure of arc JH. J is here, and now this time they want me to go to H. So from J to H, so this is where I'll use that addition postulate that we talked about just a minute ago. So 50 plus 65 makes that 115 degrees. And then the last one, number 10, wants the measure of, and notice it's 3 letters. So that means it's going to be a major arc, and it wants us to start at J, go to H, and end at F. So I'm going to go like this, all the way to F. Well, that's all the way around the circle except for this piece right here. So I could add all of these up, or maybe a little bit faster would be that I know the whole circle is 360, and I'm just going to subtract that minor arc of 65 and get 295 degrees. Alrighty, so you'll have one like that on your assignment where it's all about central angles. And that's not too bad because they're all the same measure and it works pretty quickly. But now for the more exciting piece. So now we're going to look at 11 through 18. Again, I'm going to try and blow it up just a little bit. It says that FH and KJ are diameters, so this is a diameter this way and a diameter this way. You can never assume that the picture is drawn to scale. Never assume that unless it says that it is. The measure of FHM, angle FHM, is 40, so they actually gave that right here in the picture. That's 40. The measure of HK, of the arc HK, so this is my arc. They did not give me that HK. They didn't write it on my picture. That's 60 degrees. And then the measure of arc JL, JL, this right here, is 50. So they did write that one down. So there's my pieces on my circle. That's all I have. So again, we could start filling things in if we want. There's all kinds of ways that you can find this. During class time, we look at all the different types of ways, but I'm just going to go ahead and start with number 11 and work my way down. I would suggest that you maybe pause the video for a minute and see if you can find all 8, and then turn it back on and see if you agree with my answers. So here we go. Again, feel free to turn the video off and try them yourself. The first one wants me to find arc JF. So that's this arc right here. Well, I don't really have much stuff yet to help me with JF. Haven't really put anything in. If I knew this angle right here, then I would know that it's a central angle, so it would have the same degree, but I don't know this angle. But I'm like, oh, well, this is a vertical angle here, so these two have the same measure here and here. Oh, but when I look out here, notice how this is a central angle, and they gave me this arc is 60, so that means this is 60, so that means this is 60, which means that arc is 60 degrees. Okay, let's try number 12. The arc of LH. LH is right here. Well, this is not an angle at all. There's not two pieces. It's the angle for this piece. There's no relationship there. So I instead, maybe I'm going to look at this semicircle, because I see that starting here to K, this is a semicircle, and I've got 50 and 60, so this is the other piece that would make up the 180. So 60 plus 50 would be 110. So that means that this is 70. So definitely this is not drawn to scale, but this will be 70 degrees. Okay, those were arcs that they wanted me to find. Problem 13, they want me to find the measure of angle J, and then I'm to go to K, and then to L. J, K, L. So that's this little angle right here. Well, again, I look and say, oh, that's an inscribed angle. And when I look at that inscribed angle, I notice here's my arc. That arc is 50 degrees, so if this arc is 50 and this is an inscribed angle, that means that this angle right here is half of it, or 25 degrees. Next, it wants me to find the measure of arc FM, so from here to here. Well, again, I notice that this chord and this chord happen to make up an inscribed angle. This is 40 for the angle, so that means this whole thing would be 80. From F to M, because it is double this angle. Because this was an inscribed angle, and this was its intercepted arc of that angle. Next one, the measure of angle HAK. H, then I need to go to A, and then to K. Oh, I already found that when I was having to do this piece right here. So HAK is 60 degrees. Number 16, the measure of arc KF. K to F. K to F is right here. Well, there's not an, oh, there is an intercepted arc right here. That's it, not an intercepted, a central angle right here, right? That makes up that arc. So do I know what this angle is? Well, this angle, if this is 60 and this is a diameter, that means this is 120. So that means that it would be from F to K 120 degrees. Now that's one way to find it. So that was to go from K to F. Another way that I found it is I said, well, if this is 60 and this is 80, this piece right here would be, because this is a semicircle, that would make this 40 degrees. And then I can say, oh, this is 40 plus 80 gives me the 120. So another different way that you can attack it to find the answer. Again, lots of logic involved here. So one way was to use the central angle, using this straight angle, or to go ahead and add your arcs, making them equal 180. Okay, we have two left. The measure of MK, oh, well, we just actually found that when I was adding all the way across. So at some point in time, I was going to have to do that anyway. 40 degrees. And then last I have a major arc, and it's J. So J is right here, then G, and then K. So J to G to K. Oh, well, what did I just draw? I just drew a half a circle, or what they call a semicircle, and a semicircle has 180 degrees. All right, so there you go. Your assignment will look very much like that. We will come back to these two pictures a little later in the unit and talk about them and be able to find the measures of those. You already have the information for it, but we save it for a later date. Hopefully, you will enjoy your assignment as you remember the relationships between central angles have the same arc, central angles have the same arc, and inscribed angles have half of the arc, or the arc is double the inscribed angle. Good luck!